Okay, Matrix, what I want to do is I want to link coordinate diagrams to the compound and double angles. This is from grade 11, but I'm going to link in some, matrix stuff. Okay, what if I gave you this just a sort of like a trigonometry? I said if you're given this. Okay, so you're given that 5 sine alpha subtract 3 is equal to naught, and let's plonk a restriction on there. Alpha goes from 90 to 270. How do we do that? I'm just going to explore this a little bit. You've got a trig equation and a restriction. You want to find out where the angle is, and how do we approach that? Okay, well, if you remember from earlier years, you would then, of course, get this here. We're trying to find out which quadrants we're in, and then we'll be able to establish a few things. So it's really revision of earlier years. So if we divide both sides by 5, we get that is 3 over 5. Okay, now when you talk of 90 to 270, okay, 90 to 270, that angle alpha means it can lie anywhere between there. It can lie in the, remember that's the first quadrant, the second quadrant, the third and the fourth. So it can lie anywhere in the second and third. But now according to the little rule that we do, the quadrant rule, in the first quadrant, all are positive. The sine is positive there, cos is positive here, and tan is positive there, if you remember. Okay, now where is sine positive? In the first and the second. In the first and the second. So if you think about this, if you take it, we can lie in quadrants 2 and 3 over here, and the angle can lie in 1 and 2 there. So it definitely means that both conditions are met in the second quadrant. So what we can then do is we can draw up another little diagram, and that is your second quadrant. That is where your angle alpha will lie. Okay, now what we do is we get the coordinates. We do these little diagrams. We could say that sine is y over r. Now we don't know x, but if you remember, the y is there 3 and the radius is 5 of that circle going around there. Okay, the imaginary circle that you draw. Alright, now what do we know if we're dealing with this? How do we get x? Well, we could say x squared plus 3 squared is 5 squared. So x squared plus 9 is equal to 25. So x squared is equal to 16. And then, of course, you could then say x is equal to plus minus the square root of 16, which is 4. But in the diagram, you can probably notice that the x is negative. So therefore, we're going to choose x to be negative 4. Alright, okay, so for the angle alpha, we've got a few things here. We've got x is equal to negative 4, the y value is 3, and the r is 5. So that will be for angle alpha. Okay, alright, now I'm going to give you another angle and another restriction, then I'm going to combine all of this. Let's go to a different color. What if I said to you, let's take this 13 cos and we used another angle here, beta minus 12 is naught, and I gave you a restriction that beta goes from 180 to 360. I want you to draw a diagram and determine x, y, and r here. Well, in the equation, we can say, look here, cos beta, you bring across the negative 12 and divide by 13. And where is cos positive? Okay, it's there, all the positive there, and cos is positive there. So it's in the first and the fourth. This here tells you, look, you can go from 180 to 360, because that's 180 there, and that's 360. So you can span across those two quadrants. Well, what conditions are met? That's quadrant 4, quadrant 4, quadrant 3. Clearly, the conditions are met in quadrant 4, so you can then, as we did in grade 11, put a little diagram in quadrant 4, and cos is x over r, so the x value is 12, the radius is 13, and the y is not known. Okay, so, and this would be for the angle beta. Okay, so using Pythagoras, we've got 12 squared plus y squared is equal to 13 squared, which is 144, plus y squared is 169. Okay, so then if we take that across, y squared is equal to 25. Bring that. So then y would be plus or minus the square root of that, which is 5. Now if you look at the diagram, the y value is clearly negative 5. Okay. All right. So what do we know for this angle? We've got x is for this specific angle. We've got x is 12, y is -5, and r is equal to 13. That's all for the angle beta. Okay. Now I'm going to summarize that because relative to these diagrams, we've got alpha's angles there. So let's write them down. Alpha's angles. Okay. So for alpha, the angle alpha, we've got x is equal to I'm just going to summarize that, -4, the y was equal to 3, and the r was equal to 5. And then for angle beta, we had x is equal to 12, the y was equal to -5, and the r was equal to 13. Now that was for your angle alpha and beta there. So when they say without using a calculator by means of a diagram, you go through all of that. Now at this stage, I want to give you some matric stuff. Okay, number A. Now use this information and tell me what is sine 2 alpha. Okay, now remember that alpha here is actually, it's important, we've got 2 alpha, but here we're dealing with alpha. So what I could do is I could say sine 2 alpha is 2 sine alpha cos alpha. Okay, using the metric double angle formula. And then if you then work out that sine is y over r and cos is x over r, well, what does that give you? What is the y over r for alpha? So go up to alpha's little values here. There it is. And we've got sine, that's y over r. And then the x is -4 over r. Okay, so what does that come to? Negative 6 fours are 24 over 25. Okay, try this. If I said to you, let's go with angle beta now. If I said to you, what about the cos of 2 beta? So now we restricted around about this angle here. So let's use those values. Okay, so if you look at that, cos of beta, I can use any of the formulas. Why not use cos squared beta minus sine squared? You could use any of the other two. Just bear in mind that those are all squared, and that cos is x over r and sine is y over r. And what we're doing is we're using that for, if we take this here, there we go. We're going to use beta. So what is the x value and the r for beta? X is 12 over 13. So that would give you 12 over 13. And we also have here, we're going to have for the y is -5 over 13, which is -5 over 13 here. Now let's square those. 144 over 169. Subtract. The minus will vanish, and it's 5 squared is 25 over 169. Okay, there we go. And then if you subtract that 144 minus 25 will give you 119 over 169. There we go. Okay. All right. And then number D. Okay. What about if I combine both of the angles and I do something like this? Okay. There we go. Into that part there. I think that's actually number C, if I'm not mistaken. That's BR. So this would be C here. And how would we approach it? Well, it looks to me like very much a sort of a compound angle, cos A plus B. Remember that A plus the B. Now you go to your formula sheet. Cos A plus B is cos of that alpha, cos of beta, cos A plus B minus the sine of alpha, sine of beta. So that comes to, if we then expand those like that, okay, cos of alpha, let's go and get our values. Let's do the alphas first. Okay, alpha, cos is x over r, and 3 over 5 for y over. So -4 over 5 here, -4 over 5 here, and 3 over 5 there. And what about the betas, cos and sine? Cos of beta is 12 over 13, x over r, and then the y is -5 over 13. So it's 12 over 13 here, 12 over 13, and -5 over 13. So what's that? -48 over 65. Minus and the minus is a +15 over 65. And then that equals -48 plus 15 is going to give you, if you think about that, what would that give you? -33 over 65. Okay.